This is Ms. Nakayama, and today's lesson is 8.3b, trigonometric functions of any angle. So in the previous lesson, we specifically talked about the unit circle, and those values were all from our special right triangles and our quadrantal angles. So this figure should look familiar because you had this in the warm-up. I wanted you to think about it before I just straight up told you, so that hopefully you can understand it better if you had any kind of difficulty. So you're supposed to find the six trigonometric functions of the angle theta. Okay, that's right here in our diagram. The angle theta in the diagram. So the six functions, order does not matter, y'all. All right, I got the sine of theta, the cosine, the tangent, and then each reciprocal. The reciprocal of the sine is the cosecant, reciprocal of the cosine is the secant, and the reciprocal of the tangent is the cotangent. So hopefully you realize that you are using SOHCAHTOA, however you wish to say it. So the sine of theta is opposite, which is y, over the hypotenuse, which is r. So my sine of theta is y over r, making the reciprocal r over y. Cosine, adjacent over hypotenuse, is x over r, secant, r over x. Tangent is opposite over adjacent, which gives you y over x, and cotangent is the reciprocal. Flipping that gives us x over y. Okay? Then you were supposed to find a formula for the radius. The radius is our r value. So again, using our Pythagorean theorem, you know that x squared plus y squared equals r squared, right? On the unit circle, r was 1. But now we're talking about any circle. That radius can be anything, and so we have the value r. So to solve that equation for r, I take the square root of both sides, which of course gives me plus or minus, but our radius will always be positive. So the radius, or r, in this problem is always this positive. It's always positive at this point in your life. So it is the square root of x squared plus y squared. Okay. That was your warm-up, just kind of explaining it to you. This is exactly what I just talked to you about, okay? It's the same kind of thing, and now I can find all of the trig functions for any point on an angle, okay? So let's go see what that really means and what you're going to be able to do. The terminal side of theta in standard position contains the point at negative 6, 2. Find the exact values of the six trigonometric functions of theta. So remember, at the point negative 6, 2, negative 6 is my x, 2 is my y. So I'm going to go plot that. Okay, negative 6, 2 puts me right there. Now, to be able to continue and find those six trig functions, I have an x and a y value, but I need an r value. Now, you can remember the formula of x squared plus y squared equals r squared, but some people really like to use the triangles. And if you do a triangle, y'all, you always want to draw that triangle to the x-axis. So it looks like this. And that angle, theta, in my picture, think of it like your reference angle. Okay? It is the reference angle. It is that acute angle made with the x-axis. So your triangle that you draw always, always, always goes to the x-axis. So I know that I went left 6 and up 2, so that's my x and y, and I can put it in my equation and find that x squared plus y squared equals r squared. And y'all, if you notice, I didn't put negative 6 because I'm going to square it, and every time you square a negative number, it's positive. And when people leave the negatives, they forget. So 6 squared plus 2 squared is r squared is 40, and when you simplify that, you get 2 square roots of 10. So that's my r value. Now, if I'm going to go find my six trig functions, I've got, first off, sine of theta, cosine of theta, tangent of theta. And then I'm going to go find the reciprocal of the sine, which is the cosecant. The reciprocal of the cosine is the secant. And the reciprocal of the tangent is the cotangent. So, looking at my triangle, sine is y over r. You can do that. You can just straight up use the formulas every time. Or you can look at your picture and know that you went up 2. So my y is 2. Opposite is 2, and my hypotenuse is 2 square roots of 10. Cannot leave that radical in the bottom, so I have to rationalize it, giving me square root of 10 over 10, because those 2's cancel. Now, this right here is an important thing to write down, because then when you have to flip it over here, it just becomes 2 square roots of 10 over 2, which of course becomes the square root of 10. If you flip this one, y'all, then you got to go through that rationalization process again. So sometimes it's really helpful to write down the original one so that you can see how easy it is to flip it. Cosine is going to be negative 6 over 2 square roots of 10. Again, you rationalize it, and negative 6 over 2 is going to be negative 3 square roots of 10 over 10. Again, I'm going to use this guy and flip it. So that's 2 square roots of 10 over negative 6, which becomes the square root of 10 over negative 3, or negative square root of 10 over 3. Tangent, opposite over adjacent, y over x, which is 2 over negative 6, which is negative 1/3. And again, to flip that, you get negative 6 over 2, which becomes negative 3. So that's how you do that kind of thing. All right, remember, y'all, slow me down, pause it, watch it again, anything to help you get this, because it's really everything you've done before, just putting in a little bit different application, but you know what you're doing. All right, so look at this example. It's a little different. Why is it different? Because the terminal side of theta this time contains the point at negative 2, 0. So that is what we referred to before as a quadrantal angle, because it's not in a quadrant, but it's on an axis. So that's where negative 2, 0 is. That's still my x and y, if you want to do it that way. So that means R, but I say this, y'all, because you can't really draw a triangle when it's on the axis. So that's why it's important to understand that R is still the square root of x squared plus y squared. And so R is going to equal 2 when you simplify that. So to go find my 6 trig functions, I've got the sine of theta, cosine of theta, tangent of theta. Then I've got the cosecant, the reciprocal of the sine, reciprocal of the cosine, and the reciprocal of the tangent. So sine is y over r. Y, okay, remember, this is my x, this is my y. So y over r is 0 over 2, which becomes 0. If I flip that to get my reciprocal, that's 2 over 0, which is undefined. Cosine x over r, that's negative 2 over 2, which becomes negative 1. If I flip that, that's 2 over negative 2, which is still negative 1. Tangent is y over x, which is 0 over negative 2. And I don't know why I left that off. It's 0 over negative 2, which is still 0. And this should be negative 2 over 0, which of course is undefined. Okay? So, that's all that is. Now, you don't necessarily... I'm not going to say that. If you have any questions about it, come ask me, but let's keep going. Okay, one more example, because in those first 2 examples, you were actually given the point. Okay, this time, you're told, suppose theta is an angle in standard position whose terminal side is in the given quadrant. For each function, find the exact values of the remaining 5 trigonometric functions of theta. So, you're told the tangent of theta is negative 2/3, and you're in the 4th quadrant. So, if you're in the 4th quadrant, you want to think to yourself, okay, that means the first coordinate's positive and the second one's negative. Now, if you know you have tangent, tangent is y over x. And because you're in the 4th quadrant, that negative goes with the y coordinate. Okay? Now, that's what you're going to need when we go evaluate all the functions. So, usually, if they give me tangent, I'm going to go ahead and find the reciprocal of that, which is the cotangent. So, the cotangent, of course, is going to be negative 3/2. Now, I wrote the reciprocals down to stay on track, but you don't have to do that. We can come back over here and do... Oh, poo. Didn't want that one. Didn't want that either. LOL. Wanted that. So the sine, reciprocal of the cosecant, and the reciprocal of the secant. So, regardless, we have y and we have x. We've got to go find r. So r is the square root of 2 squared plus 3 squared, because it's x squared plus y squared. And I can't seem to find it. There it is. That's the square root of 13. So, whichever one you want to do, if we start with the sine, sine is y, which is negative 2 over the square root of 13. Got to rationalize it and then simplify it. Cosine is x over r, 3 over the square root of 13. Rationalize it, simplify it. So again, remember, I told you, you always want to remember that first one you wrote down, okay, which is this guy here, because then you don't have to rationalize things twice. So that's going to be negative 3, negative 13, negative square roots of 13 over negative 2. And I wrote it like that, forgot I had put it up front. So it's just negative square root of 13 over 2. And then the secant is going to be square root of 13 over 3. Okay? All right, so the last thing that I have on the video is a few more examples of reading the unit circle that you need to be familiar with. Okay, these are a little more challenging because they're not all straight on the unit circle, but we're going to talk about how to find them. Okay, so first and foremost, instead of me flipping back and forth between the unit circle, you should have the unit circle in front of you. And all I'm going to do, and one thing you might consider doing right now, pause this video, go see if you can do all these by yourself, or go do 1 or 2 or 3 of them, go do them, and then pick back up on the video and check your answers. And because here I'm going to explain how to do them all. So the tangent of 210. 210 is on our unit circle in the third quadrant. The coordinates of that point are negative square root of 3 over 2, comma negative 1/2. Tangent is sine over cosine, or y over x, however you wish to remember it. And remember, I told you get to ignore the 2's. So this is 1 over the square root of 3. And 1 over the square root of 3, y'all, has to be rationalized to the square root of 3 over 3. So you can go through that process of rationalizing, or you can just know if the square root of 3 is on the bottom of my fraction, I have to rationalize it to that. All right, cosine of negative 225. We didn't talk about negative angles, but remember that's just a different direction. So 225 on your unit circle is in the third quadrant. If you have a negative, you're going the opposite direction, and an easy way to think about doing that is that you just flip it over the x-axis. So if 225 is in the third quadrant, negative 225 is in the second quadrant, which means my coordinates are negative square root of 2 over 2, comma square root of 2 over 2. Cosine is my x coordinate, so my answer is negative 2 square root of 2 over 2. All right, C says the secant of 780. 780 is not on your unit circle. So what we do is find the coterminal angle, and we're going to subtract 360 from that, and we're going to get 420, which is still not on your unit circle. So we subtract 360 again, and this time we get 60 degrees. And we're looking for the secant of 60, so that is 1 over the cosine of 60. What are the coordinates of 60 degrees? That is 1/2 square root of 3 over 2. And remember, we're doing the secant of it, so we're doing 1 over that 1/2, so my answer is going to be 2. All right. D, sine of negative 17 pi over 6. So this is even more different because these aren't degrees, these are radians. There are several ways of thinking it. You can go count your 6's like I was doing today, or hopefully you're good enough with fractions to know that 17 over 6 is the same. 6 goes into 17 2 times with 5 left over. So that is like 2 pi plus 5 pi over 6. Now, 2 pi plus 5 pi over 6, that would be a positive 7/6. We're at a negative, so we got to flip it over the x-axis, and we got to think a negative 5 pi over 6. So if 5 pi over 6 is in the second quadrant, negative 5 pi over 6 is in the third quadrant, which makes my coordinates negative square root of 3 over 2, comma negative 1/2. Sine is my y coordinate, so my answer is negative 1/2. So a lot of things to think about, y'all, but not a lot of work for you to show because you're going to be reading the unit circle, and you're just, if you write down the coordinates, then I know somewhat that you've found the right place, but if you don't, then I don't. And a lot of people don't write down the coordinates. All right, 11 pi over 6. 11 pi over 6 is in quadrant 4, and those coordinates are square root of 3 over 2, comma negative 1/2. Cotangent, as we talked about yesterday, is cosine over sine, or x over y. So that means that's the square root of 3 over negative 1, which is negative square root of 3. F, cosecant of 17 pi over 3. So cosecant is 1 over sine, but 17 pi over 3 is more than 2 pi. So I'm going to go convert 17 over 3 to 5 2/3. So that is 5 pi plus 2 pi over 3. Now, I haven't talked about this before, but one of the things to know is on your unit circle, this is 0, this is 1 pi, this is 2 pi, 3 pi, 4 pi, 5 pi. So if you're picking it up, all the even pi's are over here and all the odd pi's are over there. So if I have 5 pi, I'm on the left side of my circle, and then I go 2 pi. So there's 1 pi over 3 in each quadrant. So if I have to go 2 of them, I'm not going to be in this quadrant, but I'm going to be over here in the third quadrant, which I could try to, it's that green one that's going down like this on our little unit circle that we did. So that means it's in quadrant 4, and its coordinates are 1/2, comma, negative square root of 3 over 2. So we're doing 1 over the sine. The sine is the y coordinate. So 1 over, or flipping negative square root of 3 over 2 becomes negative 2 over the square root of 3. You rationalize it and then simplify it. So that is your answer. And it's helpful to know that's what the reciprocal of 2 over the square root of 3 looks like. All right, the last 3 examples. We have the secant of 23 pi over 6. So secant, of course, is 1 over the cosine. All right, and 23 pi over 6 is another one of those that is bigger than 2 pi. So I'm going to go change that to a mixed number. So 23 over 6 is 3 5/6, which is 3 pi plus 5 pi over 6. And that is, remember, 3 pi is over here on the left. And 5 pi over 6, remember that first pi over 6 I'm going to come to is going to be in that third quadrant. So the second one's going to be over here in the fourth quadrant, which is going to make your coordinates negative square root of 3 over 2, square root of 3 over 2, comma, negative 1/2. Okay? I have to do 1 over the cosine. Cosine is the first coordinate. And 1 over square root of 3 over 2, we just did an f, so that's 2 square roots of 3 over 3. All right. H, we have the sine, and it's the sine of negative 5 pi over 6. 5 pi over 6 is in the second quadrant on your unit circle, but remember that negative flips it over the x-axis. So now I'm in the third quadrant. Okay, and my coordinates are negative, negative. That's negative square root of 3 over 2, comma, negative 1/2. The sine is the y coordinate, so it's negative 1/2. All right, last one, secant of 9 pi over 4. 9 pi over 4 is bigger than 2 pi, so I'm going to take 9/4 and I'm going to change that to 2 1/4, which is 2 pi plus pi over 4. 2 pi is over there on the right, all the way around. And then I add a pi over 4, I'm in quadrant 1. So that makes my coordinates square root of 2 over 2, comma, square root of 2 over 2. The secant is 1 over the cosine. So if I flip the square root of 2 over 2, I hope y'all know that is equal to the square root of 2 because we did that in class yesterday. So that is all I have for finding the trigonometric functions of any angle. Thank you so much for watching. If y'all have any questions, please don't hesitate to come see me or email me. Y'all have a great day.